Hi, my name is Owen Gallagher. I'm a senior environmental science student at the University of Missouri, Columbia, and today I'm going to teach you how to collect macroinvertebrate samples from a creek using a server. When collecting samples, you want to take a collection of samples from multiple different areas and multiple different habitats, such as still water pools, deeper pools, runs, and even riffles.
Collecting samples from multiple different habitats and multiple different stream locations is important, as many different macroinvertebrates are designed to live in different types of habitats, such as fast-moving water or still pools.
All right, so you're going to place the server into the sediment, and you're just going to push it into the baghouse. Make sure you get all the leaves and rocks in this area as well, because macroinvertebrates like to cling onto those.
Once sediment samples are taken, it's important to invert or turn the baghouse inside out into a confined bin where no macroinvertebrates will fall out. Once in this confined area, sediment and debris can be collected and looked through for macroinvertebrates. It's important to look very carefully, as many macroinvertebrates are really small, such as this midge here. After inverting the server, it's important to look at the back of the server to make sure there's no macroinvertebrates clinging on to the back, such as the midges seen here. So, why do we collect our macroinvertebrates? Well, macroinvertebrates are a good indication of the water quality and stream health. Macroinvertebrates can be split into 3 different groups based on their sensitivity to pollution: sensitive populations, somewhat sensitive populations, and tolerant populations. These groups are dependent on how sensitive these individuals are to changes into the stream health and pollution entering the stream. When stream health deteriorates and pollution occurs in the stream, the sensitive populations are the first ones to die off. More hardy individuals are able to survive these changes and reproduce at higher rates than sensitive populations. If during your macroinvertebrate collection you find only tolerant species, this is an indication that your stream or creek that you're sampling at has poor water quality. On the other hand, if you find very sensitive populations such as caddisflies, this is an indication that your stream water quality is relatively good. Sift through all of the material that was in the server, making sure to separate leaves, as many macroinvertebrates can be found hiding on them. While at first glance it might appear like no macroinvertebrates are in your sample, turning over leaves can discover that there are in fact macroinvertebrates, such as the scud seen here. Once the macroinvertebrates are found, you can put them in a separate container to bring back to the lab to identify to family, order, or species level. Putting the macroinvertebrate underneath a high-power lens makes it easier to identify what species, family, or order this macroinvertebrate is from. After a species have been identified from your collection, it's important to count how many individuals of each species was collected. This is important to find species richness and biodiversity of this creek. Finding these 2 values can help you come up with an index to identify what type of water quality you have.